Sometimes I wonder if anyone watches my videos. Waiting for everyone to stroll in now. Anytime you feel like it. Because today was exciting, to say the least. What a day, what a day. Anybody coming in? No one wants to see me play with my rubber plane? No one? Alright, we'll go take a look at it and show everyone that's not watching what's going on. So basically what happened was, today I flew the P-51. Doesn't she look wonderful? Gosh, used to be a big, beautiful doll. Now it just reminds me of The View. Look, Joy Behar. My point is, today was all right, except I realized that this plane, it must have had something going on with it already. Yeah, I could not get it to work properly at all. It was tail heavy with nothing in the tail, and I had everything. I had a bigger battery at the front, the whole 9 yards. It was just, these little tiny warbirds, man. You just want to go, you know what? Let's see if it'll fly. See? It won't even fly for me. So, what in these are the parts I have right now. And so I decided, I was like, okay, well, what do I do with the electronics? I got some servos in there I'm going to use, some servo extension wires, so on and so forth. So I decided to put it in this, the rubber plane. Might as well recycle what I had, right? Because the body wasn't going to, I could have repaired the body, but I didn't have confidence in it anymore. So I went ahead and took everything out of the P-51, since it's 2 to 4S, and I put it in here. So now we have, hold on, let me get my stand. My trusty stand. Not my bong, not yet. That's trusty, but I don't need it quite yet. Who am I kidding? After today, I'm telling you. All right, hold on. All right, so I'm going to go ahead and power it up so I can kind of show you. I basically attached the mount to the front part where I had compensated for a propeller in the model when I modified it, because, I mean, the model was free off of Maker World or something like that. It's from the Bamboo Studio. Anyway, the point is, it wasn't designed for this. It was designed for something much, much smaller. You know, like 2S, small motor, that kind of thing. But I decided I was going to build it out of TPU. And everyone's like, TPU, that's crazy. But I have all the wings done. And I think I showed you before, this is the TPU for the AMS. So not only is it rigid, especially when you put the carbon fiber rod in there that goes all the way down, not only is it rigid, but gives you an organic ailerons, organic elevator. It's like the coolest thing. So basically, I've got everything printed up. I'm just waiting for the carbon fiber rods to get here, and then I'll assemble the wing. And I have servos and stuff like that laying around, obviously, because of that stupid plane. So let's go ahead and... Now, you're going to think me crazy, but if you watched any of the P-51 shorts or videos earlier today, you will know Okay, plenty of power for a glider. This is a TPU propeller. This is specifically TPU designed for the AMS, for the Bamboo X1 Carbon. Oh, hi, Cuddy. But I put this on the P51 today. I did all of that damage to the P51, flying the living out of it, and the entire plane is just mangled. The only part that survived was the prop, which I made out of TPU. TPU specifically designed for the AMS, which made this entire thing possible for an organic, flowing plane that's rubber. It's my rubber plane. You see? Rubber! And it'll still be stable. It's still very stable. CG's almost right, too. Can't wait to put the wing on. ESC's in. I do have to put in, get the receiver jammed in there, but I don't care if it's hanging off the side or whatever. The fact that I'm going to be flying a rubber plane is just, it's got some flex to it, but it takes some pressure to do it. So if I crash into anything, I'm not worried, because I crashed this propeller all day long. Ran it into the concrete, ground it against the ground, and still produces thrust. Ooh, stay there. Don't go anywhere. And it works. It works. You can make literally unbreakable propellers with TPU for the AMS. And now the components of the P51 have a new home. So that's what we're going with. And that's why I wanted to jump on and kind of just talk about it. Because I could have done a video, but, why? This aileron is split. You have to glue it together. But basically it'll be, I don't know how I want to do it. If I want to cut a slit out here so I can move both with like a jumper wire. Something that doesn't interfere with the rudder. Or cut the rudder back a little bit along at an angle, so I don't have to worry about it. That would probably be easier. And then once the servo is installed, basically you're thinking, well, that's moving the entire rudder. True, it is. What you do is you just take the Dremel and you put small holes in here, spaced. And that'll loosen that up to the point where it will still bend, but it won't break, because the bonding of this stuff is incredible. I know that now because of how efficiently that propeller worked. I mean, if I could show you, right? Can't get any better than that, right? I don't know if you can see it. Hold on, let me zoom in on it. And as you can see, perfect propeller. Still puts out tons of torque. So this to me is like sort of an accidental find in a sense, because I didn't order the TPU for the AMS because I knew it was more rigid. I just knew that they had changed the formulation slightly so that it could be used in the AMS, which I should have known meant rigidity, of course, because the AMS is just something, you use regular TPU in that, you're going to clog it. So you have to go straight to the, gosh, okay, that's going to have the power we need. But regular TPU has to go straight through. You have to bypass the AMS, go straight into the machine, or use a different printer altogether. But this ended up being a really big, really pleasant surprise. Just because I didn't expect it. When I initially printed the prop, I was like, you know what? I'm out of filament right now. I'm waiting for a shipment. I'll be here Saturday. And I didn't want to I didn't want to sit around. So I went ahead and printed a prop out of TPU, and I thought, well, this isn't going to work, but it's worth a shot, right? Ends up working. Ends up working perfectly. And I don't know if you saw the short, because I haven't been getting a lot of traffic on them anymore. I'm not really sure why. Maybe I'm just not entertaining enough for you. Fine. Go see another YouTuber. I don't care. I have, sorry, the aluminum gears for this showed that they made it to Compton and then they were handed off to somebody else. So they're stateside, they're in the state, and they will be here, I'm hoping, within the next couple of days. Depending on if it's USPS that picks it up from here and delivers it, if it's one of their Chinese delivery services. I have no idea, but that's what we're dealing with at this point. So dead P-51, not a big deal. Small AMS. I don't think very many people like the tinier versions of the warbirds. I mean, yeah, they're cool, but they're just... When you design an aircraft like this, it's designed for the scale that it was made at. So the way it acts in the air at this scale, and I'm a pilot. I've been doing this for a while. I could fly the mini F-22 just fine. This one has some serious CG issues. And I don't care what, you can call FMS and tell them, hey, you know what, you're a big beautiful doll, 800 millimeter. It sucks completely. So, why? And you see people flying them, but they're flying them on 2S packs. And they're not doing it without the Reflex 2, which is the gyroscopic stabilizer. Sorry, I do know English. And I don't think you could fly it without the gyroscopic stabilizer unless you're a really, really, really good pilot that happened to have run onto some meth or something. But to be perfectly honest with you, I don't see how anyone could fly it. This is a 90 millimeter. Most of you already know that. It'll fly soon, hopefully. I only say that because I never got that one to fly good. But if you saw some of my older videos that I put up, the from then to now videos, or the like introductory video on the channel page, you can see that I was flying large scale aircraft, which I had better luck with, except for the small, like the tiny F-35. It was the mini F-35 and the mini F-22 Raptor that you used to be able to get from Banana Hobby. I don't know if you can still get it. I don't know who buys anything from Banana Hobby anymore. Honestly, I would love their Super Sky Surfer again. That was like my favorite. And you'll see it on some of those videos. It was just a blast. But next up, Reflex 2 in the toilet. I have my control unit here set up for the Shrike XL. This is the same control system I use for the original Shrike drone. If you haven't seen that, you can go to the Shrike playlist and check it out. It's going to basically, this is going to control 4 of these. And if you're new here, it's lift capacity is 220 pounds. If you're conservative with its weight in angle mode and things like that, which is great for making sure you have stability, then it's probably about 180 pounds payload. To be safe for maneuverability, I'd say 150, maybe more. It just depends. I'm going to use one of these power distribution boards for it. This is 480 amps. The reason why I had issues with finding power distribution is because APD, Advanced Power Drives, decided to stop selling to us. They were like, hello from Morocco. Welcome. Smile with us. welcome everyone. Everyone that's here, welcome. Come on in, relax, sit down. We're going to talk about stuff. But yes, basically the idea was with APD, Advanced Power Direct. Sorry, I had to get my train of thought back. I have one of their boards. It's well, you've probably seen it. It's the 500X. It's the APD 500X, and I used that originally in the first Shrike drone, and I was only running 70 millimeter EDFs. And the reason why I needed that board was because the amps I was drawing from that board. You're talking about what, 70 millimeters, so it was 80 amps. They were EVP V3s from iFlight. The ESCs, they were D-Shot. Matter of fact, when I gutted it, I kind of just left it all soldered together. So yeah, your APD board and your iFlight ESCs. I got to go through all this and salvage it all out so I can put it in the next one. But it's not going to run this one. So I'll put another Shrike together just so I can have one like on the shelf to fly whenever I feel like it. Oh look, garbage. But this is what I'm going to run with. I'm going to be running 4 of the 150 amp ESCs and 4 Flip Sky 6374. It's not supposed to be stuck there. 6374 190 kV motors running through a 4-to-1 planetary gear system with aluminum printed planetary gears and a ring gear that's also aluminum. You've all seen me spin up this engine. I called it an engine. I know there's one person that's probably pissed. Turbine. You see me spin up this turbine a few times with even FDM materials as hard as nylon 6. And it still tore up the ring gear or tore up the sun gear or the planetaries. It just has too much torque on the gears. So I went ahead and, I've got my system set up here. I've got the gear carriers here for the aluminums. Once they get here, everything's nylon 6. So structurally, it's good. Wear resistance, not so good. But, oh, look, it's Wally again. But yeah, this mates up with the motor. And then these slide into here, as you would imagine they would, with the aluminum gear on them. If you're new here, this is what the gears look like, the planetaries. They slide right over, and then the sun gear, of course, looks like this, and indexes the fan through a hexagonal PETG index, which spins the fan. And so far, I've gotten to about half throttle before I've had the sun gear either get literally demolished. This is actually a nylon 6 gear that survived, which surprised me. What it did was eat the teeth out of the floating ring gear, because I designed I designed another floating ring gear for it, because the whole thing is made out of PETG and things like that. The flex was pushing the fan forward, obviously from the thrust that it was producing. But what would happen was, since these are interlocking helicals, it would put force on the ring gear that I originally designed that goes all the way into the top and is locked in with a ring. But because they're interlocking helicals, they lock the ring gear into place. So it being able to float back and forth, if there's any torque that moves it at all, keeps it spinning without tearing the teeth up on the gear. Now, I did not do that for the aluminums. And the reason why is the aluminum is going to be a lot more, well, obviously it's going to be a lot more durable. So when the drive system is flipped over to the rear, and that's already been all catted out, I just have to print it, then the aluminum gear will take up this whole, the aluminum ring gear will take up this whole section because it is stackable. So I can go 4 to 1, 16 to 1, 48 to 1, so on and so forth. But at 4 to 1, you have to times your voltage by your kV, and you get your RPMs, and then you times that by 4, and you get roughly 32 to 35,000 RPMs. So that's what we're hoping for. So that's the update on that. And the gears, like I said, are stateside. They're finally here. I assume they'll be here within a few days. Hopefully, the very least, I would say, the beginning of next week. But we'll spin this up. And then eventually it won't look like that. When the rear drive system's on, you're going to have just the front fan. Just like this. With the Madonna nipple. So basically, it helps to stop some of the restriction of airflow. I can close off these gaps on the inside of the ductwork, and I can actually have this printed out of aluminum and add the fins, which I've done on the interior version of it, so that it can dissipate heat from the gears as the air is being passed across. Plus, I'm using a high temperature paste from a Teflon, so that also helps. So yeah, turn the fan on turn the fan on and stick your finger in it? No, I will not. But we might simulate a bird strike with a hot dog once I get it running good. That'll be kind of fun. Well, actually, I think a bird strike with a hot dog at this scale, that would be more like a cow strike. So maybe a small piece of a hot dog. Let's throw it in there. I have had one of these, Bubba, it's a great, idea, for testing, but I kind of need the fingers. So, there. You happy? I spun it. Oh, no. Ow, it hurt so bad. I hope it made somebody feel better. Anyway. After that's done, which I am happy we're going to be probably spinning this up next week, or at the earliest this weekend. I gotta wait for the 120 amp ESC for this because it's in 90 millimeter. I'm only using the AVN 100 for testing. I've mentioned this before. These things blow up on me all the time. I don't like them. So I'd rather go with the regular analog ESC. This one, this has been the workhorse right here. This is the one I've been testing most everything with because it's literally 5 to 12S. So I can go from, 6S, 8S, 12S, as much as I want, to test different motors, to test different torque ratings against the pressure generated from the fan at certain RPMs, so that I have the correct motor for pushing the fan without generating a lot of heat, but it is going to generate heat, and I'll be able to dissipate it because of where it's going to be placed. But the idea was find that proper balance. So yeah, it is running at 48 volts, and it is 190 kV, and it is a electric skateboard motor. This is what it's FlipSky. I've never had an electric skateboard. I guess I have part of one now. But yeah, this has a ton of torque, and I figure, well, if it can move a human, and it's pushing a belt, to move them. And I don't know if they step it up or step it down, but if it can handle that torque, then it can handle spinning that. So, it's literally 198 grams at a maximum for the fan itself, as far as spinning weight or static weight. Static thrust will be 55 pounds. We've mentioned this before. It is 0.665 kilograms per second of air volume. So we have calculated how much pressure is going to be on the blades. There is a possibility that this blade explodes. There is a possibility that blade will explode. Once I get past 3/4 throttle to test the full burst mode, it's probably going to explode. The PLA version, it blew up with a 650K prop motor running through this with the timing set at 11.5. That unlocked some torque in it, and that just blew that fan apart. And I was like, because I had this one on the stand and chained up, I was just kind of holding it on the table when it went, and just those blades went everywhere. Luckily, this casing that I have on there deflected most of them, and they just kind of bounced off me. So, sorry guys, wasn't any major injuries to report. And I don't know why everyone's so fixated on it. You scroll through nowadays, everyone's like being like super violent, and that's the ones that get the views. Yet everyone's complaining about people being violent towards each other. I don't get, we're not going to go there. We're just not going to go there, okay? It's about stubby fan. And yes, for all those who may be new, that's what she's called, stubby fan. This is version 4. Version 5 is the drivetrain is at the rear. Giggity. So, with all that being said, the projects will go kind of in this order. So we're going to test this. Then we're going to single engine VTOL this in the garage with some vector fins back here. I have all the CAD stuff done so that I can just clamp on my servo controls and have it vectored to the point where I can, you've seen them before. People do it with regular EDFs, but standard pre-built EDFs are boring. Don't you want a turbofan like this, a high-pass fan, a 170 millimeter EDF that can push 55 pounds? That's what you want right there. That's what we're doing in RC today. And the Shrike was a concept that's working up to this end goal. So if you watch the Shrike concept drone playlist, the V10 Maiden was the final version of that. And that was basically the third scale version of this. So that'll give you an idea of what I'm doing. And you may ask, well, like most people they've asked, well, why is it efficient to have EDFs on your drone rather than regular propellers? And I say because the data that I'm collecting from all this and the research that I'm doing is because everybody wants to put an electric car or an electric form of conveyance out there. And right now you need a freaking helicopter pad or an airport to have one. And I've explained this before. If you have one that takes up no more than the footprint of an SUV but is stable enough in the air, then you can have GPS-controlled skyways, so on and so forth, on-ramps and off-ramps, literally into the sky off the freeway. And that could work. Because let's be honest, and I've said it before, you are not going to use one of these new prop-driven so-called flying cars. They're not. If you need a helicopter pad, it's not a flying car. It's just another form of a helicopter. Or a drone, which is fine, but they're externally bladed. And that causes a problem for the infrastructure, for society. There's no way you're going to integrate that in. And if you do, it's going to be only for the rich. It's only going to be for the people who can afford it. The idea is to create something that people can afford. That people that can get on and go, you know what? It's done charging. I'm going to run to the grocery store. Screw traffic. I almost flipped off the camera. Screw traffic. Fly over the power line. Sit down in a parking spot. Go in and get your stuff. Go back home. Or fly close to the ground. It's going to be programmed to where it stays a certain distance off the ground like a quad would. So you're basically going to turn it like a quad. It's going to require leaning, but it is going to have an angle assist system involved. And those motors, like I said, will be 3 times this size when they go in the quad. I mean, who wouldn't want to do that? Who wouldn't want to get on a quad that has no tires, just these right here, right there, and just fly around? I mean, everybody else is doing it with jetpacks and everything else, but it doesn't require you having to strap on the backpack, strap on the fuel tank, light up your fuel burning engines. I'm doing this all with electric. That's why I'm gearing it the way I'm doing it. That's the way I am. That's why I'm running the specific kind of motors that I am. I've got my amp meter, so I'm at idle throttle or a hover throttle, I'm pulling 11 amps, 11.5 amps with this motor. And that's still putting out a significant amount of thrust. Why TPU for the gears? That was just for fun while I was waiting for the aluminum ones to get here. That was more or less me trying to, just spin it up. I was curious to see if it worked, because if it worked for this propeller. It worked for the P-51. It worked for this entire body. It worked for the entire wing for this glider, because it's a different type of TPU, because it's designed for the AMS. So it's a bit more rigid, but still has flexibility, and the layer bonding is unmatched. You're not pulling it apart without a vise and a pair of pliers. So, but remember, if you're gonna try something like that, try and build a wing or anything like what I have already for this glider. I have, like I said, I have all the sections here, and they're very, very rigid. They're rigid. They're tough. You can't penetrate them, but it was single wall print. Single wall. So you've got single wall prints with extremely tough surfaces. It's extremely rigid, and you get that organic aileron that you're looking for. And all you have to do to loosen these up a little bit more is to take your Dremel and put small holes, or drill, spaced apart at specific distances to make this aileron a little bit more flexible, if you like. Or you could try it with a strong servo and just go with full organic movement. But, I printed all the wing pieces. They're all here. And everything's ready to go. I'm just waiting for the carbon fiber rods so we can get that going. And let's see. This is the pack I ran with the Shrike. Everyone doesn't believe, they're like, this is what was on my drone right here. And that was the FDE colored one, the version 10. And it flew for almost 5 minutes. And that's pulling, almost 400 amps. At full throttle, I would say 400 amps. Conservatively, it was about maybe 200, 250 amps at a hover. When I was maneuvering, closer to 350 amps. But it was interesting how it moved through the air, and that's what led to the Javelin. That's what led to you're using polycarbonate. Is that just regular PLA? Yeah, that's just regular PLA, isn't it? So this model was actually designed to be printed with a lightweight PLA. And I thought, no, we're printing it with rubber. We're going to put a bigger motor in it. We're going to put a bigger battery in it. We're going to do some slight modifications. And we're going to make a cool glider. And with the carbon fiber rods, it'll have the rigidity. But it'll also have a natural dihedral. So it'll give it the ability to stabilize itself in the air when you're not on the ailerons or when you're not on the sticks. As long as you have the throttle at the right point where it's actually maintaining altitude, and the trim on the elevators are good. The natural dihedral from this, I think, would be awesome, especially with the carbon fiber rod. So that's all and not to mention the durability of it. If you watch my P-51 video that I did today, it was the last video I uploaded, I beat the living hell out of that plane. That plane's gone. Gone. Everything on that plane destroyed. But the prop never broke. Never broke. Couldn't get the plane to fly straight at all, just because the CG was always off on this plane. It never flew right. So God, I miss my gliders. I miss my gliders. I do. I used to do the big gliders. I used to do the nitroplanes. I had a Raven that was, gosh, it was a pretty big balsa wood gas powered plane, and I loved ripping around with that thing. It was so cool. The sound, the aerobatics you could do with it. Those are more the types of planes I was into. I don't mind flying the foam gliders and things like that. But this whole new era of 3D printing has brought in the ability to print planes. And we thought, okay, great. We can do it with PLA or PETG now. And now they've come out with this lightweight PLA. So now you're back to the fragility of foam. But you have to wait for hours for it to print. So, and I'm fine with PLA Aero or a lightweight PLA. I'm fine with it if you print it as a rigid structure. If you print it as a thin wall structure, like they have with some of the 3D lab print planes, if you're lucky enough to get a rigid part, or a finished part that doesn't have any defects in it, it's very, very fragile. It's very unforgiving what happens to it. But what if they took this rigid TPU and its bondability on its layer adhesion, and they somehow adapted that to a lightweight filament? Because this is, I'm telling you right now, even the support material that I had to pull off of some of my TPU prints, I did normal, so it would just do like the cross-section grids. You could not pull them apart. You could pull them off the model, because of course it was designed that way, but you could not take the supports themselves and tear them or pull them apart. Their layer adhesion was remarkable. So if we can find out for absolutely certain what TPU uses for that bonding strength, because this is more rigid. You would think just the regular rubber standard TPU would be one that has some serious layer adhesion. But this seems to be a mix that is perfect for airfoils if you design them correctly. For rigidity, for strength, and definitely very forgiving on crashes, as you can attest to this prop right here. Because that thing, if you just watch the video. Just watch it's oops, I did it again, because I crashed the P-51. That's what it's called. And I was just amazed. No matter what I did to this plane, that prop would not break. It's amazing to me. So accidentally finding a use for this kind of material in an application you wouldn't necessarily think would be something you would use, it's a find. It's like gold. Print any prop you've got out of the AMS TPU, I guarantee you'll be impressed. Is there some flex? Yes, obviously. On some of the bigger, thicker, more rigid props, there won't be as much flex, but there will still be that durability. You're not going to lose prop tips if you tip it into the ground. You're not going to lose tips if you grind them on the concrete, if you nose in after stopping or whatever. I mean, I can't say enough about it. So far, when it comes to Bamboo Lab filaments, this one is the one that I am the most impressed with. Because I'm using it for everything. I've decided basically the entire plane is going to be TPU from Bamboo Lab, specifically designed for the AMS. So I'll get the exact chemical composition. I think it's on their site. But they may guard it closely. Who knows? But the real excitement comes when I get this thing spun up again. A couple of shorts I have back. I spun this up with the floating one. I actually mentioned before I spun it up that it was a floating ring gear. And it started screaming. It was getting up there. And I got almost past half throttle before it ate up those gears. This thing's going to scream. I mean, I half throttle. That's all I got. I was burning maybe 50 amps at a max at just over half throttle. Uh, I mean, the engine says it peaks at 80, but it can handle like 120. It's designed for torque because it's designed to move weight because it's designed for a skateboard. So it just made sense logically. No matter what something is designed for or built specifically for, its capabilities were what I was looking for. And in most RC motors, I could not find those capabilities. I couldn't find the torque I was looking for. I couldn't find the power I was looking for without putting one of those huge agricultural DJI drone motors on there. And that would cover the whole face. One of them I had did cover almost the entire intake. So the engine had to be way out here in order for it to clear ductwork for a jet. But this particular engine is usable in a jet. This cowling comes off, and then you can put the internal system inside of a jet that you've designed around it, and use it as a jet. You don't have to have this ductwork on it. This is strictly for testing. Other than that, I just wanted to kind of jump on, say hi to all my friends who usually watch me. Hopefully make some new friends. And that right up there is the original Shrike. Like I said, if you go to the playlist and watch it, you'll see where it went to where it came from to where it went. And it was just a really cool journey on that one. And it was a learning experience for me with flight controllers and how they respond with EDF engines. But then I had to go to the next stage. I had to go to the next stage because they didn't have bigger EDFs that were in my price range. I mean, I'm not going to pay $5,000 for a Schubler motor when I can make something that's going to put out the same thrust with a skateboard motor and a 3D printer. Your wife left you because you ate 19 pudding cups. Why didn't you go for 20? I mean, hell, you were already in 19. Should have just rounded it off to an even number. Why leave it on an odd number like that? That's just weird. I think she probably would have stayed with you if you would have went with 20. I think the problem with you is cohesion, math. Being even. Maybe she took it as a sign. He's not going to be fair in a relationship and do things evenly. He's always going to take one more. But yeah, I would have done 20. She probably would have been fine with it. So, and take it from somebody who's been married for 16 years, almost 17 years. And I know these things. You're going to eat 19 pudding cups. Just eat 20. Go all the way, man. Don't get to the top and say I can't do it anymore. This guy's like, I'm gonna leave you because you ate 19 pudding cups. Well, I'm eating 20 now. I'm a new man. I'm sorry. I just saw that and had to say something about it. It was funny. Getting AMS and use PLA for the supports because TPU doesn't molecularly bond with PLA. Well, yeah, I mean, that's a good idea. That's a very good idea, actually. I'm also trying to do hydrogen. Amber Marine, welcome. I'm also trying to do hydrogen and a type of hydromagneto drive for my outboard shop. Well, that's cool as hell. I want to use hydrogen eventually. Basically, hydrogen fuel stacks for power. I want to get that. I want to run it off of hydrogen because I honestly want to know if I'm going to get more power density out of the hydrogen fuel cells or the stacks for these engines rather than running lipos. to get more runtime. And that was one of the experiments that I'm going to try next after structurally it is proven. Once it's proven, after the Metal Gears arrive, then once I get it past, once I can get it to full RPMs, once I can pull it back to 3/4 or half, and it's sustainable as far as no wear, no major gall on any of the gears, things like that, then I can kind of move forward past this stage to the stage where I turn this into what I want it to be, and then start experimenting with power systems. I even thought I was even crazy enough to start looking at beta voltaics, and then as I say that, 3-letter agency enters the chat. For me, it was about, and they're like, well, yeah, they do beta voltaics, but for on small batteries, but they're in the microamps at this point. And I'm thinking, you guys have never seen a nuclear reactor then, because there's no way we can't make a 48-volt battery that can handle a 500 amp current draw with a small beta voltaic system. Now, I understand the risk involved. I understand that inherently putting something like that on the public nowadays would be catastrophic, because people would have other ideas with them, nefarious plans of some sort. They go, ooh, we have a beta voltaic, this or that. Let's go, that's just the state of the world. So I say fight nuclear fire with nuclear fire. If it comes down to it. But I don't want to be limited on what it is that I research with, just because there are bad actors in the world. And that is what really kind of limits us sometimes in the hobby, is there's technologies out there that we could be using right now that could make more efficient, safer vehicles that could do a lot more, that are way more versatile. And we're limited to what the government's going to say. Okay, well, you can have this, or you can't have this. So, put us through a vetting process if you want to. Put us through licensing. Put us through classes, whatever you want to do, to give us access to the power systems that we want to experiment with when it comes to trying to make more efficient systems. That's all I'm asking. Well, okay, that's one way to enter the chat. Yeah, Amber, that would be a great idea, I think. The great part about DC at this point is it runs underwater, so anything's possible. As a matter of fact, you'll love this. This plane was designed to fly, obviously, because it's a plane, as I mentioned. Well, I feel stupid. But it's also designed to land on the water. So it lands on the water, has some fins to guide it. It is going to have a fin at the rear for yaw control. TPU tanks, fake gas tanks at the tip for buoyancy in the water. It'll pull air in through the bottom duct to tread water. And then once I want to pull out of the water and get airborne, or gain speed to get airborne, the tanks at the end help with buoyancy on the water's surface. And then what ends up happening is when you throttle up and pull back on the elevator, you won't get waterlocked by water flowing in through here, because we'll be able to, if it does, you'll still be able to pull in air from the top. And that'll pull the front of the craft up out of the water. And so I went with wheels so it could go on the land. I also went with a skid to go through mud and snow and hard surfaces with an annoying sound. So this plane was designed to be, air, land, sea, all the above. So that's one of the main goals of this. So after I'm finished with the wiring and I get everything done, I'm going to be doing some, water treatment, waterproofing treatments, I should say, on the bottom side where the buoyancy areas are. And I might just print sheets of TPU and just CA glue them on there. That seems to be working so far. But yeah, it'll have on the rudder, it's going to have more yaw authority here because I'm putting in a vectored fin that comes off of this. That will also help it in the water. And also the same thing with the elevators. I'm going to put another rod through here. That's going to help. So as I pitch up, then it's going to pull up. It's going to push that bottom end down and then pull that front end up, free up those ducts. And then that's going to allow it to get pulled out of the water at a specific speed. So there's going to be a lot of testing of this. There's obviously going to have to be a lot of testing of this after I'm done getting all the wires around and I've waterproofed everything that I need to on the outside, like some of the servos that I have that aren't already waterproof because I'm broke and I can't afford them. And so I'm kind of going with what I got. So that'll be the next set of testing for that aircraft. Let's see. I'm trying to follow you, man. I'm trying to follow you. Yeah, I need funding. Who doesn't need funding? I'm almost done with my degree in industrial engineering. Then I'm going to move forward to aerospace, so on and so forth. And then, but I started thinking about what I already knew going in. And I don't know why it's hard for people to get an engineering degree. I mean, I don't like the math myself, but I've gone through 65 credits. I haven't even opened up a textbook. And it's all just, I don't know. I go to sleep listening to physics books. Mainly because I have tinnitus and I have to have something to distract me. Another product of the war. Thank you. No, I'd do it again. For my country, I'd do it 100 times. And I just wish they'd pay me 100 times worth because I'm not getting that much right now. Okay. Well, I gotta go tuck the little ones in. So Mama and I are gonna go do that. And then we're gonna head to bed. And then I'll be back again. As soon as I get those Metal Gears show up, I'm going to come back on, do a short, tell everyone they're here. Actually, I might do a live unboxing of the Metal Gears so we can both see if they're good or if they're crappy. Because I've never received anything from PCBWay. So this is my first. And it took literally a month to get everything here. It's stateside. I ordered it on the 1st of the month. And it's just now, like, in Compton. Why it's there, I don't know. I'm Northern California, but hey, whatever. Throw a dart. Not everybody hits the bullseye. 1 month, yes, 1 month, and I will discuss more about that later on as soon as it comes in. I'll show you the invoice. I even posted something about it, but I'll show you the invoice, order date, when it was received, all that good stuff. But we'll get there. But I do have to run because my children are waiting. And that's who I'm doing all this for. Hopefully so I can make more than what the government pays me so I can give them a life. That's what I want to do. Plus I want to entertain all you guys with the insanity that's floating around in my brain that I just have to freaking build. So if I accidentally discover something new, I'll probably accidentally discover a wormhole. Oh, like an artificial one. Like on total accident. And it'll probably be because I'm microwaving a burrito and I dropped a magnet. Some crap like that. Sometimes I get lucky like that. But you all have a wonderful evening. Thank you all for stopping by. I appreciate it. For everyone that's new here, please like, subscribe, share it with others. I appreciate the support. And Amber, we'll talk about that collab because I'm interested in what you're doing. And we'll see what we can do about working together to see what we can come up with. So sounds good. You all have a wonderful night. Love you all, and I will see you again soon. From all of us here at DPC, which is me, so all of me at DPC, we wish you a wonderful evening. Good night.